Okay, so first let's plot some data in Python. So we're going straight into the action. You've got the Ubuntu machine running, you've got Python either on the Linux machine or directly in Windows with Anaconda, which is what I will be using today. And we want to plot some data. That is something that you'll have to do in the lab or for different projects. So of course we want to plot data, and most of the time we also want to fit it. This is how we extract some physics from the data. So here I'm showing again the GitHub page to install everything. So all the instructions, and you hopefully have noticed that I added a lot of things and edited a lot of things since the video last week. So here you have the link to the video, and I've added some tips on how to upgrade to Windows 10 to access this Ubuntu subsystem. You have the instructions here. Last week, we were talking about using Emacs, but personally, I've been having some issues using the GUI. So, and there's also a learning curve to Emacs. So it is totally fine to use gedit instead for now until I figure out how to make Emacs work properly. So gedit is very similar to Word. So if you've ever used Word on Windows, all the same commands will work, and you simply have to install it like everything else. Okay. So this is what I assume you have, and it's very good that everybody tried to install things. Hopefully you ran into some challenges that you had to overcome. Some people ask questions in the WhatsApp group, which I'm happy that you communicated that you had some issues. And today I'm also going to include a small tutorial on Googling, because this is what I do when you tell me you have a problem. I use Google and I look for a solution. So we will do some data plotting and also some Googling today. I've also edited this. So a bunch of issues that came up in the WhatsApp group, I made the instructions clearer or edited some things. Here, what I want to show you is at the bottom of everything. Last week, I showed you a link to a Python workshop. So we will start with that today, just to show you what is actually in there. So when you click on that Python workshop link, you come here, and it explains to you how to go through this guide, through the workshop. They're all Jupyter notebooks, and they are very nicely organized. So you can start from scratch with Python, and you have a lot of information. So here, I gave you instructions on how to install Anaconda and Spider, sorry. And you have other instructions here if you would rather use Python in Linux or something else. Instruction to Python and coding in general. You have classes, dictionaries, loops, all of this. But I will let you go over this on your own time or with your colleagues. That could be nice to help each other out. Today, we will focus on the plotting over here. So the first link over here brings us to this Jupyter notebook over here. So already, without understanding all the details of Python, there is a lot of information here. So first, we will import some libraries, very important. And the two most important ones in Python are usually matplotlib and Numpy. So we will work with that. And we will go through another example in a second, but I just want to show you what is on this page. So it introduces you to plotting some data points. You have those lines here, how to plot and show the plot, and this is what you get out. So with just a few lines already, we can plot data, which is the goal of today. And some more functions to put labels and titles and grids in the back if you like. all more aesthetics things that you can do, all the different settings that you have available. So first, there were just 4 data points over here. And with those lines, he added labels, titles, a grid. Continuing, we can add lines between the data points. We can show markers at the data points. Again and again. After plotting just different plots, what we call a scatter plot, we have function plotting, where we define a function here and the markers for data points. So that is something else that you can do. Again, I'm just showing you where the information is so that you know where to find it. So we can plot functions or a smooth function without the markers. We can plot different functions on top of each other. We can add a legend, very important. We can have log plots or log plots. All the lines that you need to do that are already there. And you can save the plots to a file. So just on this page, you already have a lot of information available and you already have the lines. So what you can do if you want to make your own plot, you can simply copy those lines and make your own code by taking bits and pieces that you find in these Jupyter notebooks or on Google. So that is already a lot of information that you can use, that you can build your own code with this. And the last part over here, the useful SciPy functionalities, curve fitting, is the second notebook I want to go through. So here we will also import SciPy. And after we plotted all our data like we do here with the title and the labels and the markers that we want, we can define a function that we will fit to our data points. So this is what he is doing here. So that is it. That should answer a lot of your questions on how to plotting data. And now we will look at another example. But all the information, a lot of information that is the most commonly required in the pracs or in the lab or in projects that you do, you already have the information just on those 2 pages, and you can copy and paste those lines and build your own code to do exactly what you want to do with your own data. So this is there available. So we will look at another example that is not already linked there. So if we come back again to our GitHub, I attach another Jupyter notebook that is called the Muon Flux example. So if you download this and open it in a Jupyter notebook that you can get, for example, in Anaconda. So I installed following the instructions on this page at the bottom, how to install Anaconda, Spider, and Jupyter Notebook on Windows. I have all those 3 over here. And I downloaded the Jupyter Notebook from the top here, and I open it in there. So I already have it open over here. And this is an experiment that I was teaching to undergrads when I was back in Canada for Physics 409. And we were doing the analysis in Python, of course. So here I am sharing it with you. And again, it is attached right here for you to use. And my colleague, Danielle, is already telling you that you are free to copy and paste this code into your logbook for your lab and modify it as you see fit. So depending, again, you won't be doing the exact same Muon Flux experiment, but starting next week and in the following weeks, we will be in the lab, we will be looking at some data, and you can use a code that is very similar to this. So this is, again, a Jupyter notebook, and he goes through first a new very useful library in Python that is called Pandas, that does many things. many useful things and very advanced things also that we use in postgraduate studies and high level research, such as machine learning is it's much easier to do machine learning using what is already included in libraries such as Pandas. So we can use this. This is one way to import the data. So here you can see that with the lines over here, he pulls the data directly from a GitHub repository to import it into the code instead of having a separate data file. So after the notebooks that we just seen here, you can already use those lines to plot data. So I don't think that is the biggest challenge in plotting data in Python. Personally, I think the trickiest part is how to import the data, because the data that you have will be in different format. It can be in different types of columns. The columns can be separated by a space or a comma or a tab. So that can become a little bit tricky to make sure that the code understands the data file that you want it to look at. So here he does that by downloading it directly from another GitHub. So we don't have to worry about following another data file. And then once we have accessed the data file, we need to read this data file. So this is what this line here does. And that is using the Pandas library. However, most of what we do, a library that is very useful to do plots and fitting curves, is using the Numpy library like we saw earlier. So here he converts this Pandas format into a Numpy array. And then we have different columns. So, okay, first let me show you the data. So here I went to the website that he says here and the name of the file, and this is what we have. So using the lines in this Jupyter notebooks, it goes straight to this page and imports this data directly without giving it a separate data file because it takes it directly from online. So here we have a list of angles and counts. This is what we call the Muon Flux experiment, the cosmic ray muons coming from everywhere in space and the atmospheres. And using two scintillators, as such, we use two scintillator paddles to measure how many muons we see at different angles. So we have those two paddles and we rotate them and take another measurement. So here, those muons would come straight down. That would be 0 degrees. And then we rotate a little bit and we see the muons that cross both scintillator paddles until we reach 90 degrees like this. So this is just to give you a quick background of what is the data we're looking at. You don't have to understand all of this, but we will do something similar to that in the pracs in the next weeks using sodium iodide detectors. I don't know if anybody's familiar with detectors like this yet, or will we all jump into this next week or in a couple of weeks? Also, I can't see the chat. Maybe I should say that. When I'm sharing my screen, I can't see the chat window. So, okay, nobody is saying anything, but just background information, we're using two scintillator paddles to get counts of muons as a function of the angle that we rotate our paddles. And this is what we see. So at 0 degrees, we see almost 4,000. And then as we move the angles, the number of counts tend to go down until we are at 90 degrees. So we go from 0 degrees to 90 degrees. Anyway, those are the numbers that we want to plot. So yes, once we have downloaded this data and converted it to a Numpy array, we want to tell it what we're looking at. So we're going to make two lists. We have first a list of data from the first column and a list of data points from the second column, which are counts. And this is what we see in the data file directly. And then just to check that everything is working as it should, that it found the right columns, we're going to print the first list, which is called angle, and print the list that is called counts. And then we see again those numbers that we successfully imported from that data file. So we have the numbers. Now we want to plot it. So those are the same lines, very similar lines to what we just saw in the other Jupyter notebooks. So we use matplotlib, and a new line that we add over here is we are interested in error bars. So we plot the error bars of X and Y, and we define what is the error bar, Y error, for the Y value, which is the number of counts. And in statistics, in radioactive decay or statistical processes, we will see in the next weeks, the uncertainty is the square root of the number of counts. So this is simply what we define here, square roots of counts, which is the number of counts, the list that we use over here. And we plot everything here. So we have another plot of data that we know exactly where it is coming from, and we see a special behavior. And now we want to extract some physics. So of course, we are going to fit a function to this. So here we're going to use SciPy and a curve fit. Curve fit is usually a safe bet. And here from the background of the experiment, the introduction of this experiment, we know that the number of counts should follow a cos with an exponent, a cosine function to some exponent, and we will probably expect an offset over here. So we want to define this function over here. We do it as such. There's many different ways that you can do it. Here is one way. And of course, when we do a fit, we want to know how accurate it is. So I'm not sure if you're already familiar with chi-square calculations. Maybe, maybe not. But once we get there, you know that those lines are already available. And here it shows you how to calculate this chi-square. So here we just define a few functions before we actually calculate our best fit, which is happening here, which is our data fitting. We use curve fit using the function that we defined just above on the value X and the value Y, and how to calculate the uncertainty. So we're not going in detail in the uncertainties and the physics here. We're really focusing on Python, and I'm going over those lines just to tell you that they exist and are available. And then we create the plot. So here, remember we had this plot here with nothing on it. And here we plot everything we just calculated on top of it. So we plot the best fit line with the equations and the best fit parameters, the chi-square value, and a legend is always in order. If we plot more than just one thing, we want to know what we're looking at. So we identify the data points over here and also the fit line. So for most projects, most pracs that you have to do, this is the end goal. You want some data and you want a fit that's from the coefficients and parameters that you extracted, you can understand some physics. So from this is the third notebook we're looking at already, and you can do uncertainties, you can do chi-square calculations, and you have a full identified plots with titles and labels and legends. So everything that you need, you have in those 3 notebooks. Like I said, I think personally the trickiest part, because it is quite simple to find all those lines. So I've shown you 3 examples. You can Google how to plot anything in Python and you will be able to find help, because Python is widely used, and we're focusing on Python, but remember it is the same for any language. So in our group, we use more C++, and if we have issues, we Google it, we find someone on the planet who already had this issue or already tried to do the same thing. And please share the GitHub link again. Here, oh yeah, I can put it in the chat. And also we shared it in the WhatsApp group a lot, so you should be able, okay. So like I was saying, you can do a lot of things from this, but I think the trickiest part is to import the data. So here we have an example where the data is located online on GitHub, and we can extract it using this. Most likely you will have your own data set in the lab, you will have your own data file, and you want to import it into a code. So first you can define the list by hand. You can type all the different data points, so you don't have to import anything at all. That is one way. A second way is to download something from online. What I want to do is have my own file and import it in my file all locally on my computer. So what we're going to do now is we're going to edit this code in order to use the data file that I have over here. So let's do that. I showed you, I went to the data, the website, the link where the data is. I copied and pasted this in a file in my notepad and saved it as muonscan.data. So I have the exact same data, and now I'm going to use Spider. So first, instead, so here is a way to convert from the Jupyter Notebook to a simple Python script. So I copied and pasted all the text that he uses here. So I took the first block, the second block, and the third block, copied all of this and put it all together in a script in Python over here. So if I run it as is, it should give me the same thing. So I run this, and here in Spider, I click on plots and I see what is coming out, the plots. So first, when he finished running the first block from the Jupyter Notebook, we read in the data points. So that is still working. And he did the first plot without any fits. And then we added the second plot with the fits and the equations and the legend. So I just copy pasted everything and everything works fine still. So that is good. But what I want to do is to import the data directly from my computer. So like I said, I already saved the data as the file name. First thing we're going to edit here, I called it muonscan.data. So that still exists. That's still available. And now if I just, I'm going to comment things out. So that is a trick that is very important when you try to edit a code, especially when you know that a code is working and you want to work on it. You don't want to delete anything, because you want to be able to always go back if you figure out that you broke something. So instead of deleting lines, I'm going to comment them, adding a pound sign in front. So I will no longer need to go on GitHub. So I don't need this line. However, I'm going to keep the file name where I define this. So the only place I have to input the name of my data file is over here. And everything else after that, all the places, the instances that use file name are still working and are going to refer to my data file that I have in the same directory as the Python code that I'm running. So I'm keeping this line and I no longer need the URL. So I can comment this. I don't need to download anything, so I will comment this out. And here we want to read the data. So he will access my file name and I want to read it. So here you can see all this line just refer to download, which was the request to download the URL, which was the directory plus the file name. So I can, I'm not going to delete this, but I'm going to use something very similar. So I'm going to copy this line, yes, paste it here. And instead of using everything from the GitHub, I'm going to directly use my file name. And sep is the separator between the different columns. So let's try it without it. Let's just go with file name. Yes, he's not complaining. And see what happens. So we're going to save this and run this and see what he says. Index 1 is out of bounds. So he's not happy with that. What I want to do, if we go back to the file name, to the file, here we see that there's no numbers on the first line. So what we have to do is we have to skip this line. So first, let's go back to if I kept this, would he have been okay? Yes, so we had a different error. So to read the file with this function here, with the pandas function, we will keep the separator. So here we can see instead of going to GitHub, he's using the data file that I have over here, which is copy paste what is online. So if this is working, if the functions that I work is working, I should get the exact same thing out. And I did. So he printed out the data points again, and I got another set of figures. So that is another way to import the data. So that, that happened quickly. That's not many edits, but just by changing, by commenting out, removing those lines referring to the GitHub and using the local data file instead of the one online, everything works the same. So right now I have a Python code that is plotting and fitting the data directly on my laptop. So the first way we saw to import data was to write down the lists, like the first way to import data, we write the data points directly. We write the list by hand. Second way, we imported it from GitHub. Third way, we are using Pandas. Wait, Zoom is in the way. Where is Spider? Okay, the third way, we used Pandas to read a file that is our computer. No, I want my plots. Another way, a last way, a way that is more common than using Pandas. Like I said, Pandas is a very useful library and a very powerful library. However, we don't have to go there. We could straight go to Numpy. So I don't know how to use Numpy to import data. So I want to see different ways. And this is where Google comes in handy. So this is my data, and this is Google. So I want to find another way to import the data. So I go to Google and I say, I want to load a data file in Python and see what people have to say all over the world on how to load data files. So the first link that I have here is 5 different ways to load data in Python. That sounds promising. So I go here, and at the top of the page, we see 5 different ways, and you can read all of this. There is a lot of important information. And the first way is a manual way, which looks quite complicated. I'm sure it works, and there's some explanations about it. You can go through that, but pros and cons, it is a little bit complicated. What I already know is that Numpy is quite useful. So I'm interested in this function over here, which is Numpy load text. So this is very similar to the line we were already using for the data file and using Pandas to read the CSV file. So instead, we're going to use a line like this. So I'm going to copy paste this line here. So I'm going to comment this line that still uses Pandas, and I'm going to use this here. So the first argument that we have in the parentheses of the function is the name of the file. I already defined it above as file name. So that is it. And daily meter is, we have this thing over here that is a tab. I will put it like that. Now let's try to run it. So I just changed the function based on the library. So first, if I do this, he tells me that NP is not defined. I'm trying to use Numpy. However, I did not import it at the top of the file. When we copy pasted from the Jupyter notebook, he decided to import those libraries lower in the code. So what I'm going to do is just cut them and paste them at the top. So I didn't change anything, but the point at which I call those libraries. So now I want to use NP here, Numpy, and I need to import it before I do that. So I put it on top and I run it again. And now I have a different error. So the function load text has an unexpected argument, which is daily meter. And yesterday it took me a while to understand what the problem was with that. So first, I, of course, Google the function. I want to see how does this function load text work. So here I have zoom again in the way here. I Googled the name of the function and it brought me to the direct website of Numpy, and I have all the details of how this function works. And you can do that for any type of functions, for any type of library. There is tons of information online. You just Google whatever you want and you will find it. Can we have this code that I'm using? It is already available. If you go back on the GitHub, I already uploaded it over here. It's called the Muon Flux example. So it is already there for you since yesterday. Okay, we're going back to looking how functions work. So here I tried blindly to copy and paste this function into my code, and he's not happy with it. So now I need to understand what's wrong with it. And you can see all the different options that it can take, all the different parameters that the function load text can take. So first, what is required is fname, the file name. We gave it that. And if we go back, he actually complains about daily meter. So I'm going to go directly to this. And what I see is that the parameter is not actually delimiter, it is the limiter. So there is a typo. That was it. If you see, it's delimit, while here it's actually meter. So when I copied this comment blindly, Python didn't know what I was talking about. It's not delimiter, it's delimiter. Now let's try that. And we have another mistake. So it means it went past that, that issue. So we're doing some progress. We're going further and further down into the code. So what he's saying now is that he can't convert this string to a float, the angle degrees. If we go back in the data, he's looking for numbers. He's trying to make a list of numbers, and the first thing he encounters is a word, or strings. He can't make a number out of this. So we wanted to skip that line. So I'm going to go back to my definition of the function of load text, and I see there is an optional parameter that it can take that is called skip rows. So that sounds promising. It is optional, and it tells it to skip the first skip rows line, including the comments. So the default is to skip 0, which is what he's trying to do right now. He's not skipping any line, skipping 0 lines, and he's running into issues because it's a word. It's a string instead of numbers. So we're going to go back here, and we're going to add an option, skip rows. And we don't want to read the first line. We want to skip at least the first line. So I'm going to do skip rows equal to 1. So if we look here and he skips the first line, he should just be reading numbers and he should be happy. He should not complain. So let's try that. What now? So Numpy array as new attribute to the Numpy. Here, so you see we've passed another challenge. He's happy with this line and he does not complain. So he goes to the next line. And here we were using this line earlier to convert from the Pandas data frame into a Numpy array. But we are already loading the data from the data file to Numpy format. So we no longer need this line. And that's why he doesn't know what to do with it. So we're going to comment out this line. But now I'm referring to data. So what I'm going to do is go back here and change this to data so that df is no longer in use. And the Numpy array that here we call data is what we define it here. So I had to go back up one line to make sure that the definition work. Now, if I run this, he should be happy. Yay! So again, he printed the same data as before that he extracted from the data file, and I get my same 2 plots again here with nothing on and with everything on, the fit and the parameters, the chi-square, the legend, all that good stuff. So that was a 4th way to import the data. And right now, the 4th way took the longest because we had to do some editing. But if you start your own code, you can start from this and you can see that it's actually much shorter. It's only 2 lines to define the file name and how to load the data from this data file into things here. So why I went through all of this with you, this is to show you a 4th way that you can see is actually the simplest way to import data. If you really want to, you can do it in 1 line by skipping this file name definition and just putting the name of your thing here. The only thing, if you use a data file directly, it needs to be between, I don't remember the name in English of this, but you see it needs to be in between this, just like the delimiter over here. All those little tricks are all here in all the definitions, and you will learn the syntax of Python and any other language that you want to use. You have those little things here that personally I remember are very annoying, but it's a new language, so you have to accept some things. So the last change that I did here is just I got rid of this file name line definition and I simply run it there. And I could also run this and it works just the same. So in one line, I can import the data file, tell it how the data is separated, all the different columns are separated. And if they are headers to the columns, I can also skip those lines. So in that single line, I've imported all the data and I'm ready to get into action, plotting and fitting functions. Everything is the same down here. So I think that could be a fifth way to import the data in just a single line. By doing this editing, hopefully you picked up some little tips, like when you have a working code, never delete anything. You can comment things out. You can make as many copies as possible, which is what I did here. So yesterday I did a copy, I edited everything, making sure that I could get to import the data in different ways. And I kept it on the side in case something went wrong today, but I just made a different copy. So scripts in any language take 0 space on your disk space. Have many copies of the codes, especially when you have a working one. Do not touch it and do not delete anything. Just comment things out. It doesn't cost anything, and you're sure that you can always go back and compare how different lines, different edits you did can affect the data. At the same time, little tips: when you require some libraries, you always need to call them before you want to use them. He reads from top to bottom. So when we were importing Numpy lower here to plot the data, he didn't know, before we imported it, he didn't know what NP was. So we need to make sure that the libraries are at the top. And it is the biggest part of programming is to debug things. So errors happen all the time. I think it's impossible for code to work as is the first time. That is totally normal, nothing to panic about or worry about. This is how we learn. It's little challenges that we overcome and make us much stronger. So every time I edit something, I run and see what he's not happy about. And usually Python give us good hints as to why he's not happy. And we just need to understand its language and see why he's complaining. So here you develop a sense of becoming familiar with some error message to understand what he means. When you're not familiar, you can Google it. As always, Google is the most important tool. So when he's not happy with something, you can Google anything. And you have a lot of information for specific functions. So here, even if we used only 3, or we gave it the file names and 2 optional parameters, there are a lot more parameters that this function can use. So depending on the format of your data file, for example, if it has different headers, the different delimiters, depending what is between. So some data files are recorded with commas in between, like this. So you would need to tell it how to recognize the different numbers, the different strings that are in there. And this is only one function. So this is why programming is so powerful. Everything has a lot of parameters. It can do literally anything that you want. You just have to understand its language to speak its language and tell it exactly what you want and how you want things to look. So here I told it where the data is and how to import it. And then for the plots, the same thing. You can tell it exactly where you want things, the size of the titles, the labels, the numbers. Those are all things that you have power over, that you have control. You just have to ask some colleagues or Google and figure it out. And of course, there's always people who want to help you, and in the WhatsApp group, we're there also to get you when you get stuck. But the satisfaction and the confidence that you gain by trying things out yourself is invaluable. This is how you will get to become comfortable with everything. And this is what I wanted to do today. I wanted to show you where you can get information. So we're not just throwing you in Google or by yourself. I already showed you reliable sources of information where you have already explicit functions that you can copy and paste. So this is what I've done. We started from this Jupyter notebook here. I copied everything, took out things that I didn't want to do, and added things that I wanted to do. So that I kept the rest of the notebook to use this data, but in a couple of weeks when we do experiments or pracs in the lab together, you can change the name of the data file, and maybe the format will be different. You'll have to play a little bit with the functions, play with the name of the columns if you like, the name of the lists. The range of the numbers, the function that you'll want to fit, the number of digits you'll want to keep, everything will be just a little bit different. And you should be comfortable just going into the code and having an idea where things are so that you can make it your own. Are there any questions? Did I lose anyone? Is anybody still there? Thank you. So someone understood things. And everything I just showed you, again, comes from the GitHub Ubuntu setup. The link for the workshop is right here at the bottom. And the Jupyter notebook for the Muon Flux is over here. And in Zoom always gets in the way. In the Jupyter notebook, you have the link to go to the data. So you can copy this link over here to go to this data file, which is there, if you want to play with this exact data. So that is an example of data. You can take any data that you like. You're totally free now. You have the code, you can play around, and you will have to play around in the next weeks. But now there is no pressure. It's just you enjoying programming and understanding, trying to understand how computers talk, the different languages, and how to get unstuck when you are stuck. And again, Google is everything. Google can get you unstuck from a lot of things.
Can I ask?
Yes, hi.
Since I was a bit late. So you're saying the Muon and the Jupyter, you got it from Google Street, or we have to install it as one of the programs?
The Jupyter notebook here? Yeah, how you can open it. I personally open it through the Jupyter notebook here. So when you download Anaconda, it comes with many programs, many functionalities. So one is Spider, which is what I was showing here. And in the Jupyter notebook, I click this. this terminal opens and he, can I do it again? Let's try this. So, okay, yeah, I can open two at the same time. So in Anaconda, I clicked on Jupyter Notebook and then it opens in a tab, in how do you call that? A browser. And then I navigated where I saved the Jupyter Notebook, physics over here. And I can open the Jupyter Notebook directly from there. That is one way to open a Jupyter Notebook. And that is the way that I would recommend, because it comes with Anaconda with everything. So I'm just getting started with Spider, and I find it very powerful. It comes with a lot of tools. Like you can see, it complains when something is wrong. So that again gives you some tips as to why is unhappy. So for example, here the complaints are that I'm importing libraries that I'm not using anymore. So importing things doesn't do anything, but to get rid of those complaints, I could just comment them out. So I recommend Spider from Anaconda, and at the same time, Jupyter Notebooks come to it. So today, everything I showed come from Anaconda on Windows. You can also have Anaconda and everything on Ubuntu, but I haven't personally tried it. But you can Google the instructions and try it for yourself. Does that answer your question? They said we should use, okay. So I have.
Yes, thank you.
Okay, good. Thank you for your question. And now I have a few questions in the chat. How do you get X-Ming to open a window when running Emacs? They said we should use gedit so long. Okay, sure. It doesn't, yeah, so last week we were trying to get everybody started on Emacs, but I haven't been able to open a file from the terminal. So if you remember last week, I was just trying to do Emacs, for example, open my bash RC. So it seems that if you do this, it should open the file directly. However, it hasn't been able to do that. It opens the GUI, and then I need to go and find my file for it to open. So that's an extra step that I'm not happy with. So for now, you can just use gedit. We have in the WhatsApp group, there were lots of questions about X-Ming, right? So X-Ming is just running in the background. So it's not supposed to do anything obvious. The only thing you want to see is the X-Ming server. You want to see the icon at the bottom right or wherever all your icons are. So here I know X-Ming is working, and it was on before I opened my terminal, so that when I tried to open something, for example, Emacs, it opened in a different window. Earlier in the WhatsApp group, we saw that Emacs was in the main terminal and didn't have the clicking function. So that told me that X-Ming was not on, because this is what the GUI, the user interface should look like, where I can click things, which is very nice. So I changed instructions, as you can see here. You can just use gedit. So gedit is very simple. It is basically Word. So I'm going to open my bash RC script in gedit, and I have it here. So this is all it should do. It still complains about not having some things, but it works fine and it opens. So this is what it should look like when X-Ming is working. I'm trying to erase this. Okay, so if you open something graphical like gedit or Emacs or root, it should open in a different window and you should be able to click things. this will not work if X-Ming is off. And a lot of the complaints in the WhatsApp group were about things like that. Another thing I want to show is, you can see I opened my bash RC script, and the first line is the export display that some of you found as a solution to do this. I'm a little bit concerned that it's not already in your bash RC, but you can check. If it's not already there, you can just paste it there, do source bash RC to reload your script, and you will never have to type it again. So make sure that it's in your bash RC script, and you will never have to worry again. So I wanted to say that if it's an issue of yours that you're not able to open Emacs or gedit or anything graphical in another window, and you made sure to open X-Ming before, then make sure you have that display line. It will work if you type it in the terminal, but you will have to do it every time unless you put it in your bash RC script. This is the same reason for root. We want you to add this line so that you don't have to type it in the terminal every time you want to use root. And every time you edit your bash RC, you have to source it so that it reloads it and looks at the new edits that you've done. So I think those are the last issues that I remember from the WhatsApp group. Are there any other questions? Is Nico here?
Yes.
Ah, okay.
Nico is always here.
Perfect. Nico's here. Okay. So, anybody, any students before, any questions from the students before I gave it to Nico?
No question, seems.
Everybody.
Okay. I wanted to ask, we haven't used any Fortran compiler yet, right?
No, I haven't used Fortran.
So, okay,
but we installed it if we did GitHub, the root installation properly. Here it should be.
Okay. Yeah. Okay, but okay, let me take over. I'm going to share the screen quickly.
Yeah.
And I'm going to explain a different method to plot data.
Mm-hmm.
I'm going to also implement it by getting that data. So what I want to do here is we're going to run a Monte Carlo simulation. So, but the whole purpose is plotting that data. I just want to show you how to run it, just for the heck of it. So we have, so what first thing is, we're going to do our sudo apt cache search, and we need to find, let's say we want to find the latest Fortran compiler. Fortran is another language. Coda G Fortran. Let me see. I put my password here. And there's a lot of Fortran compilers. I can see here, there's 8, which for instance, I don't have the 8, but I'm going to check if, let's see, okay. G Fortran 8. So I will take the latest G Fortran compiler. So basically, once we have identified it, I'm just going to do sudo apt install, and I'm going to install the G Fortran. I don't know if you can see. Can you see what I'm typing here? Nikita, can you see that?
Yes, I can see.
All right. So I'm going to also look at the different libraries that come in my repository, or your repository also. And I want to run these ones also. This one, the dev, which will be useful as well. And I want to see what else do I need. Probably also these ones. And these ones. So you press enter. And it says doesn't like to install this. Let's see whether we can install just the libraries. Here we go. Wow, so it's 87 megabytes. And we're going to install the Fortran libraries to compile programs which look like this. So ls2.f, extension is F. And this is a single program, a very simple program. Actually, not so simple, this one. Which, okay, here, let me tell you what I did here. When I have ls2 star.f, ls2, if I go to my bash rc file, bash, let's say Emacs bash rc file, and I do Control S ls2, you see. So basically, when I put the alias in such a way, I'm shortening the time, I mean the structure of what I want to write down. So instead of typing ls minus lrt, which tells you what did you modify last to list in that directory what you modify that last, I just type ls2, which is equal to this ls minus lrt. So if I do that in a directory that we were running right now, in this here, ls minus lrt, you see virus 3r is the last one, but if I do ls2, also is virus 3r, right? So it's telling you everything, what is the latest file that you actually use within this folder, correct? So now, now I want to run this, which is a Monte Carlo. It's a little bit more complicated than what we saw last week, but this is, we go through one of our pracs and learn a little bit of Monte Carlo. So this is basically a Monte Carlo of the pandemic COVID-19 spread throughout South Africa. But I'm not going to go through the details right now. I just want to show you, where is it? It is here, okay. So this virus 3F, we're going to compile it with the latest Fortran, and probably we have the 8 right there, minus O. Then we put the name of the executable, whatever we want to call it, virus 3, and then the name of the Fortran file, virus3.f. All right, so we have created a file, which is this one here, virus.dat. And this virus.dat is, let's see, ls2. This is the latest file, which is not the one we just created right now. We say it was created at 2311. So maybe the G-Fortran, let's say, I'm going to use the G-Fortran I used before. I'm going to compile that file, virus3.f, okay, ls2, and then I'm going to run virus3. Okay, now we are running virus3, which is the file we just compiled, and we are writing all these numbers that come out here to this file called virus.dat. So ls2, and you can see that virus.dat is the last file that we have modified, and we modified at 2:22, which is the time right here, right? So now we can open this thing. I like to open with ngedit. So it is a program. I'll show you why. And this, so ngedit is there, but we need to call it the file, ngedit virus.dat. And here we have different columns. So this is a new program I would like you to install, sudo apt install ngedit. Another editor, which I have installed already, but I will show you why it's so useful. So say you have a file with lots of columns, right? But I'm only interested in the last column. So then I type Shift, I press here where I want which column I want, and then I do Shift Control And with the mouse, I just drag, but obviously I'm missing this one. So you're going to do it a little bit to the left here. Here we go. Shift Control, and I play Shift Control, and with the mouse, with the left button of the mouse, I just drag the whole column, and then I do Control C. Remember, Shift Control, and then with the mouse, you press on the mouse first and drag down, pressing the left button of your mouse, right? The left one. So you just drag it down to the end of the column, then you do Control C, and then you can open an Excel file and say, okay, I want to put this thing here, and I'm going to just copy that table, okay? And now we have the Y column. So now let's say this was a calculation from the day, let's call it the rank 1 equal 1. This is actually plus 1. Plus 1. That's 2. And then we drag down your Word file, I mean your Excel file, drag down and do Control D. You see, has added 1 unit to this left column, right? So we have an X and a Y. So I'm not telling you right now, maybe the X has to be changed, just giving you what we have here. And then I'm going to take this thing here, and we're going to make Control C. And we're going to make a new file, which we're going to call whatever, and edit. And then I'm going to do Control V, and I have the, and then I'm going to call this edit save as data. So data.dat. Basically, I'm going to call it an extension dat, which is for data. I'm going to save that thing. I'm going to check if it's there. You see, it's right there. ls2 is in my alias, and I can call the last file, which is data.dat. And now, what happened? Let's see what happened with this file when we plot it. So let me again come from the beginning. So we have a Fortran file here that we have compiled. We have created an executable as if you press the up arrow in your keyboard, you will see what happened before, whatever you did before. Up and down arrow, you see, up and down. It tells you what you did before and what you did later, right? So we did this, and we may change these parameters, which we discuss later on what they are in a different prac. I just want to introduce this possibility just for you to learn how to compile. And this virus.f is in our COVID-19 mini school, this Fortran file. So you can take it from there. We know what the mini school is in the same GitHub that we have for the Plex. So you go to the UWC nuclear GitHub, and then you get the virus 3.f, which is a Monte Carlo simulation using the Planck's quantum model of the photons. As you remember, the black body radiation. So we are using a similar distribution where we are including the temperature and frequency and things that we have adapted to COVID-19, but basically from quantum mechanics. So this is something which I will explain tonight, then giving a colloquium at the University of Notre Dame in the US. And you can, if you want, you can attend that. I will explain in more detail how we use quantum mechanics to explain COVID-19, roughly. So now, but then this is the situation. We have a program, we have compiled it, like we did this here, boom. With this compilation, we get an executable, which is called this one. This is the Fortran file. It's always the same, gfortran, whatever is your compiler, minus O, virus 3 is the name of your executable, can be anything. We can call it Monte Carlo, South Africa, and then ls2, and you have here Monte Carlo, South Africa, right? So then to execute Monte Carlo, South Africa, we do this and press enter, right? And then again, we get the same file basically that we got here. I'm going to minimize this because we don't want that. Basically, we get the same file, the same virus.dat. As I told you, we use ngedit to open this virus.dat because it has the possibility to click here and say Shift, Control. While you're clicking, just go down and copy that column, which I always find very useful when you have these kind of files, because you can take any column, right? Really, you know, we want to take this column in at the beginning. So again, you see, if you don't do Shift, then you do that, right? But you do Shift, Control, then you just select beautifully the column you want to plot on your Excel file. So now that we have in the Excel file, we have converted, we have copy and paste on our new file, which we have called, let me close this one, ls2, we call it data.dat. If we open this file, I think we did before, but if not, we open it again. It's obviously the columns that we have in the Excel file, right? So let's go to the last one. I like to see 44470. Let's make sure that we did the right job. 44470, 250, 250. That's the right thing. And here 1020. So we go to the beginning. To the beginning is 1020, 30, and the next one is, let's say, 19. 19 is 13, which corresponds to this right line here. Okay, now we have a data file. We can again open one of the. I don't need this anymore, not for the time being. So then we want to sudo apt install Grace. So Grace is a program which I already installed. So I already have the newest version, but you install it yourself and you execute it like this, xmgrace. And xmgrace, I press always an and at the end because that allows me to keep using the terminal as I wish. If I don't do that, if I do xmgrace and I don't type the and, you see, there's there's no possibility to type anything because it's waiting for me to kill this one so I can type again. So what I do always, every time I execute a program on the terminal, I place an and at the end so I can keep using the terminal and type whatever I want to type there. So now we are here and we want to plot the data. You want to plot the data, and this is a very powerful plotting program, which is similar to Origin in Windows. I tested many years ago. It does many things very similar to Origin, which is one of those gurus plotting programs that is used with Windows, I think. So data, then we do data, import, ASCII file, and you have this data here, right? So we can make X and Y, we can make X, Y. If we have another column with uncertainties, we do X, Y, dy. That will be giving us X column, Y column, plus uncertainty of the Y column, right? It gives us different possibilities. It can give us the possibility of an error also on X, an error on Y. So there will be a data point with an error bar on the top, with an error bar horizontally. So it will be one of these crosses that we see. So allows us, but we didn't put any error. So we're going to make a XY and we're going to plot the data. Okay, and then here we see how basically a Monte Carlo simulation of South Africa is happening right now. And this is what we see. This is the total number of deaths here. But this is for, let's see, 150 days, 200 days, 250 days. So this is probably for, we have to check the timing at the beginning, but this is probably for the second wave. I think we calculated for the total 60, 63. Yes, this must be just for the second wave. So this virus.3.fortran is for the second wave, and you see that the second wave will go. Then we can click here on the y-axis and say, okay, death or cumulative and death, right? So we can check here what is happening. We can change this to whatever font we want. We can change this to whatever font. I like the Helvetica, but doesn't need to. We can make this spacing from here. We click here, and instead of auto, you specify it, and you can move this away from the numbers. As you can see, we can make this a little bit bigger. Normally, for editorial purposes, when you write a publication, this is generally around 200. I use. Okay, so close. Let me see, close, and then I'm going to move this so I can see this better. So basically, we can increase these numbers by tick labels, and then this is 100. I normally use 150. Okay, and then I use also for the x-axis 150. So when you publish this figure, everything is 100%, right? So again, x-axis, we're going to I like the Helvetica better. And again, we're going to go here, axis label bar specified instead of 14. We're going to make it 16. As you can see, move to the left. If we make it a little bit, 19. Move a little bit more to the left. That was a little bit too much. 18, let me see, 18. Oh, 18, no, 89. So 18, apply, accept. And then this will be the, on the x-axis, we will have the days. So on the x-axis, we have mainly days. And this will be sometime in September, October, or November, see, November, December, January, February, yeah. This will be sometimes in August, September, when this started to happen. And we see that the second wave is hitting a number which goes around 40. We can change also this one and say, okay, between 0 and 50, make it all this, make it 9. As you can see, just 31, 32, 33, or you can make it 5 and make this 4 if you want to change the axis, right? And then you have 5,000, 15,000 to 20,000 up to 50,000. You can change this plot, make it straight, line, make it thicker, the line, make a different color, apply. And basically, also here, we can change the x-axis to this guy. We can make it, again, Helvetica. And we can change the character also to almost 200. Let's go there. So days, we say auto specified 0.09. It goes a little bit down. As you see, and we have a very, we can change this axis here also. We change the x-axis, so instead of 300, let's make it 250, because that was our calculation for. And that's it. You see the typical flattening of the curve from COVID-19 from scratch, from zero. From a Monte Carlo simulation, we just plotted the total number of deaths will be around, as you can see around here, around 45,000, right? For the second wave. So then we can make a straight line here. We want to say, create new by formula. We want to have 25,000 here from 0 to 300, a length of 999, whatever, apply. That was 25,000, but we don't want 25, we actually want 45. Apply, accept, right? Accept. This one, I don't like it, so I kill it. Kill. Hopefully, I'm killing the right one, yeah. This one, I'm going to make it a dash line because it's not it's just a line which is showing us. Of course, this one, and this one also is, let me see. I'm going to kill this one because there are two of them. All right, so then this green line, we can make it bigger. And basically it's telling us the limit of accumulated death in South Africa. Okay, so this is what the Monte Carlo prediction is telling us by using the Monte Carlo, the Planck model the quantum model for the photons that you know very well. You know, from the black body radiation, each object emits a radiation, a thermal radiation, which can be approximated by a black body spectrum, a black body curve. And this was the beginning of quantum mechanics, because to reproduce this heat, this radiation from any object, was needed to quantize the energy, right? In energy equal h bar omega, or h nu. And this was the beginning of quantum mechanics, because Planck had to do this trick to be able to reproduce the black body spectrum, or the radiation coming from the sun, from the bulb, from yourself, from Mars, you know, everything has a black body radiation, a black body spectrum that you need to fit. I will tell you lots of information, like what is your temperature, or what is the temperature of the universe, or what is the temperature of the sun. You know, this is the typical curve which looks like that. And this is the curve that we are using to make this Monte Carlo simulation. So today is the day of, is the World Quantum Day. You want to know more about this? At 10 p.m., I'm giving a colloquium at the University of Notre Dame. But so far, this is what you have. I want you to go back to the video. I've been a little bit too fast, but everything is explained there. Go back and forth, you know, how to get the column, how to type it, how to put it in the spreadsheet, how to copy, paste, make a data file, and the data file can be plotted here. And this is the curve that you get. So we can type here and say window, drawing object, text. Then we can say here, Monte Carlo, Planck simulation, for South Africa. So then we do Helvetica. I increase a little bit to 150. I can move it. You can add anything you want. This is a very powerful plotting program. We can edit the object. We can make it a little bit bigger if you want to. So, right, you can move it. So as you can see, we have here used quantum mechanics to explain something entirely different, as it is the distribution, the pandemic trend of COVID-19 for the second wave, going up, 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 and then flattening the curve as we see right now. Okay, guys? Any questions? I think this is spectacular. I mean, I've done it very fast, but for you, you just go back to the video and explain how to do that. I mean, here we can change also this axis. In terms of days, we can say, okay, in terms of days, I want every, every 4. Here we need 1, 2, 3, 4. I have, 60, 70, 80, 90, 100. I can tell you what is the initial day, but I think it was sometime in August. We have to figure out. But basically, this is telling us to the day of today what is happening and how the curve is flattening. Guys, people, any questions? Or are you too amazed by these things? Tell me. Hopefully you're not being scared of, but just being motivated to do something different. Nikita, everything okay?
Everything is okay on my side.
So there's any questions? I mean, I explained things probably too fast, but that's why we have the videos for, right?
Yep. Mm-hmm.
So let's see who is here. Ansil, do you have any question?
Also, not at the moment.
Not at the moment. So I see some people in the PC lab right there. Mm-hmm. So anyone has any questions in the PC lab? Guys?
Anyone with questions?
Thank you, Sune. Thank you so much for being around. I just see you there. Any questions? Where is Shad? Is Shad here or no?
Nobody in the lab has questions now.
Ife?
Yes, Prof, I'm here.
Shad, here we go.
Yeah, I don't have any questions.
But everything was clear, guys. I have something on the chat. A little bit fast, but the pace is a little bit fast. But we will try to keep it up. Shoki, I know it was fast. Sorry about that. But you see, the Monte Carlo, it wasn't my purpose to show you this. It was just this Monte Carlo prac. We'll do it later on. I just wanted to show you how we compile the Monte Carlo, the Fortran file, and how we extract the data, and we make 2 columns, and we plot it on xmgrace. So this was the only purpose, and then how you play. You need to open xmgrace yourself and play around with it. You know, this is the only way to learn. Okay. So, and again, as I say, we have the videos there. So we can put the videos on. Maybe Nikita, it would be nice to have the videos on Canva also. You know, the links. If they do VPN, they can access the YouTube videos without any cost. Is that correct, Chat? The YouTube videos,
Yes,
they don't cost you any money.
Okay. That's free. Yeah. Using the VPN, you can even use YouTube for free also. That's what I picked up on my side.
Excellent. So then, guys, that's what we do. We can open the video anytime we want, slowly. I am from Spain. I speak fast. You know, I just everything is too fast. I'm not. So I want you to go back to the video and slowly say, put it in slow motion. So I sound like more like an American, or you know, something different. Okay, guys. Any questions, Tife?
So I think the student, like the first hour with Nikita, they still need some time to then go through it slowly, practice, and then to run also the script. So right. Yeah.
So tomorrow I want to.
And
right. So tomorrow you have crack mail in the PC lab. Sunaid, also for you from 10 o'clock. Is that okay? I think. Can we open the PC lab tomorrow at 10 o'clock? Just for anyone, if they want to come by, they can come by and ask Craig any questions. Okay.
Nico, can you hear me?
Yeah, Sunaid, I can hear you now.
Okay, so I don't mind opening up the lab for anybody who wants to come, but is anybody going to come?
Well, that's right. So if we don't want to open the lab if nobody is going to come. So guys, do you want Craig Mel to come by tomorrow at 10 o'clock? And so Sunaid opens the lab. So who is up to keep learning? Craig knows all these things, how to plot data, how to use xmgrace. So Craig is a super machine. So how do you want to come tomorrow?
Guys, you guys gonna come because I'm not gonna come here for nothing.
Right.
I will come if you need me to be here. You're gonna come. Okay, I've got one hand over here, Prof. 2 hands. Who else? 3 hands.
So 3 hands. Anyone else? Shoki? Shad? Just come by and you can learn anything you want from xmgrace or, you know, from the Python coding. Also on the chat, you know, on the WhatsApp group, we can ask. And Nikita is always too fast. She works overnight and too late to answer your questions, which I don't think is very healthy. But you know, we can this issue of online teaching, it makes you work 24/7. So I don't want us to fall for that. These guys can wait until the next day. So you don't need to wait until midnight, go to bed at 1 o'clock in the morning. Yeah. They can wait.
That was an exception so that everybody gets set up. But now we assume everybody is set up. So now, and I've given you a nice tutorial on how to Google. So I expect more from you from now on.
Right. Actually, that's a very good point. Everything is in Google. You know, whatever we're teaching you here, you just go and be smart in the way you ask Google. Professor Google, you have to be kind with him, but he will answer every question very precisely. What you have to do. We don't know if it's he or she. It's probably both. a linear combination, like anything in quantum mechanics, but you can ask Professor Google anything you want. Salman, anyone wants to ask a question before we go? Songeso? Asile, did you get the money? Okay. So guys, if that's all, I think I'm done. We are done for today because again we provided probably a lot of information.
Mm-hmm.
Yep, the pace is a little fast, but we will try keeping up. Yeah, Shoki, you keep up because the tools that we provided these last 2 sessions will be very useful for you to prepare beautiful pracs. I don't want no copying from pracs. You know, from last year, from the year before, everyone seems to believe that copying from the previous prac last year is the way to go. I want us to bring everything we have learned in these last days here, to make plots with xmgrace, to make plots not with Excel, you know, to make professional plots for, say, for publications like we have done today, right? So I want us to go over, and we're going to learn if you have been copying pracs from previous years. So I want us to do something first independently, you know, and something pretty ourselves. Mm-hmm. Okay. With that, I think we can call it a day, or at least half a day. Nikita, thank you so much again for such a nice presentation today. And thank you, everyone. Thank you, Sunet, for being around. Tife. Actually, I don't know if I introduced Tife to you guys before. Tife is also going to be your coordinator for the
next week. We're gonna meet next week.
We're going to meet next week, all of us, for the oscilloscope prac.
Yes.
All the pracs have been, Israel has sent you all the information on eCanva. And next week, we're going to learn how to practice with the oscilloscope. So I want you not to fear to connect this cable, to touch that thing. You touch everything. If we break it, we ask the dean for another one. So, but you guys just touch, you know, and see what this is for, what is that for. You know, I want you to read the prac, read the manual that we're providing you, and play around. Okay, no fear. Guys, if there's no more questions, I have to prepare something else. Okay, thank you so much, everyone. Bye-bye.
See everyone next week.
See you next week. Thank you, Nikita.
Thank you, everyone.
Bye.
Thank you, Nikita.
Bye.
Bye.